Okay, the other thing we might vary in order to increase power is the tasks we give people. If we can control or manipulate those, we might be able to find out something different. One kind of thing, which is I just want to think, used particularly in sort of human factors and ergonomics experiments, strangely not so much in HCI, but is very, very powerful, is distractor tasks. And this is about increasing the effect size. So the things we've looked at already are about reducing the noise or increasing the number. This is something that actually can make the effect a bigger effect. What you're trying to do is do something. They've got the main task that you're really interested in. Perhaps it's a comparison between systems. Perhaps it's a particular psychological effect or cognitive effect. And then what you do is you create a secondary task that puts extra load on the user. And what you want to do is push that person up to the point at which something breaks. So it could well be that you've got two systems. You believe your new system B is better than the old system A. You believe it causes less effort for users. But people are really good at coping. They deal with the most rubbish systems and actually get on with it. So what you do is you give them another task. I mean, a classic might be to ask them to count backwards. Years ago, I used to work in agricultural engineering research, and there the classic one was to give people a simulated tractor task where they were both using some equipment but also trying to drive a straight furrow through the field. And by doing that, you try to make things worse. So if you look at the two little diagrams at the bottom, you can imagine if there's the mental load of tasks A and task B. B is taking more load than A, but if they're both below the person's mental capacity, then you can't see anything. But you add the distractor tasks to both. That takes up some of their mental capacity. Condition A is still fine, but condition B pops over their cognitive limits, the person starts to make errors, and then you see things. This is a bit like that back of the crowd in the Trump video. And said it's particularly helpful if there are coping mechanisms and people do things that mean they manage even though there's load there. Another thing you can do, which again is about increasing the effect, is to have a very targeted task. This is a bit like the targeted users in a way. You choose a task you believe will expose the effect of the intervention. Some years ago, and I'll pop it here so you can have a look at it, there was did some work with Steve Brewster from Glasgow, who's now at Glasgow University, and he was interested in adding sound to buttons and whether that could reduce errors. And there was one particular kind of error that he was interested in, and it was when you move over a button and you press down, usually if you slide off and let go, it cancels the action. The button doesn't do it. This is for on-screen buttons. What he noticed, and I assume this was in his own behaviour, was every so often he would fail to have clicked the button. He'll have thought he'd clicked the button and failed. And he realised what was happening was he was slipping off the button, letting go, and not realising. He tried adding sound feedback to the buttons, but in experiments, because it was an expert slip, it never happened. Basically, novices took a lot of care when pressing the buttons. You never saw the error happen. So the question was, how could we actually see this type of error happen, given it was an expert slip and given people doing experiments? So we thought a lot about exactly how it happened. And what we did was we deliberately created an experiment where people had to click the button but very quickly move off to click another button for the next trial. So it was like a calculator typing task with a confirm and then a next. We deliberately made it so when they moved down to the next button to press it, they couldn't see whether their feedback from the first button press. And so they go to click the button, they start to move off, and their brain tells their finger, lift finger, it also says move, and sometimes they come in the right order. By creating that very targeted situation, suddenly, in short experiments, we were able to get people doing 8, 9, 10, a dozen errors in quite a short experiment on something that was normally an expert slip. We were then able to add the sound feedback and see that it didn't reduce the errors happening, but meant that people noticed straight away rather than it becoming a problem later on. Again, though, by having a very targeted task, it makes generalisation more difficult. You have to know that you designed this targeted task, and therefore take that into account as you try to work out how that generalisation could happen. So, more extremely, you can be almost demonic. You could have argued that was a demonic intervention in itself, but there are actually more extreme things you can do. We're again in a different set of experiments. We were interested in the way that, for instance, when you drive a car, if you're reversing, even if you're not a very good reverser, sort of if you oversteer, you just know to do the opposite thing. You might not know what to do, but you know to do the opposite thing. And we wanted to look at those kind of tasks. We wanted to use a Fitts Law-ish kind of experiment for this. Not quite Fitts Law, but something like that. But what was quite important was people moved and overshot. But actually, we're quite good at not overshooting. We tend to undershoot and then do additional corrective movements. And I think that's to stop. That's because in real life, if you overshoot, you knock things over. So what we did, we added an artificial additional error to people's movements with their mouse that was very unpredictable and was quite substantial. It meant people hated you because it felt bad, but it meant they got lots of overshoots. Now again, this meant it was very, very unrealistic as an experiment. So in terms of generalisation, you had to be much more careful about the way you framed it. And as I said, the subjects hated us. Another ongoing debate within the field is between whether you have laboratory experiments or in the wild experiments. But also, even if you're in the wild, if you're using a system in a real setting, you might do things to constrain that setting. The trouble is, if you just go to people and say, do what you like, the level of noise, in the sense of the uncontrolled things, are huge. They might choose to do different things, they might be in different places. Classic of this might be, say, a tourist guide and all the different ways people can use it. So in one sense, if you can control things, if you can put them in the laboratory, if you can make the situations semi-wild, you perhaps put them in a natural setting but make them do a fixed set of tasks, then you actually reduce the noise. The problem with that is, again, generalisation. So we have this issue that you've got something that's very constrained. How will that work more broadly? And the way you deal with that, just like other things, is you have to use your head. You don't use the data, use your reasoning. An example of this was a colleague of mine, Nigel Davies, with some of his colleagues, was working on a mobile tourist app, and it was in the times when people were looking at using the camera to actually detect what was being looked at, and then to allow that to give information about it. And one of the issues was, what happens if the image recognition is actually a bit faulty? So what they did is they set up a Wizard of Oz experiment where people used an app, used the photograph, a person or human would see the photograph, match it to where the person was, the thing they were looking at, and then the system would deliberately add a little noise, would sometimes make it wrong. And that meant the noise was tunable. It wasn't something given by the image processing application. But in order to do that, they stripped out most of the application's functionality, just so the person would spend a lot of time looking at things and using different methods to locate what they were looking at. And therefore they would get enough data to be able to make some sort of sensible comparison.